Hello everyone, welcome. In yesterday's presentation by Frederick and Jay, they shared the details on what Crosswork Workflow Manager is. And they shared the new release feature and improvements. And today we will take a closer look into CWM. We will try to connect the dots to understand what it does, how it works, and how to work with it. We will see CWM working with other systems like NSO and NetBox. We'll start from understanding what workflow is, and then we will have a quick refresh on CWM. And with that, we'll move to hands-on writing of workflows. After that, we'll move to part 2, and we'll talk on how to DIY your own adapter. And we'll do that with the help of SDK and XDK. And with that, we'll conclude this presentation. So let's connect first few dots and look into what workflows are. When we think about automating tasks, we usually target one single task, usually related to one tiny piece of that can be automated. And usually it is related also to one single platform. So examples of single task would be provisioning device, or upgrading operating system on a device, or applying a configuration, while workflow would be a sequence of automated tasks. So we will have each task executed one after another, and usually it would trigger more than one platform. An example here would be a workflow that is doing onboarding of the device, combined of the tasks that is first provision device, then upgrade operating system, and then apply the configuration. So we can illustrate the workflow as a series of steps that needs to be completed sequentially. On that note, let's go to CWM and connect a few more dots there. CWM is an execution engine. It can help us mitigate human errors while executing repeatable workflows. We ourselves will define actions, integrations, and the complexity of the workflows that we want to execute. We can create separate workflows per each of our use cases, and then reuse some of these elements in other workflows. CWM also integrates to many other external systems, and it does that with adapters. How is it done? Let's imagine each of the tasks would be interacting with external systems like NSO, like NetBox, or any others. This communication between CWM and this system would be done with the help of adapters. CWM enables multi-vendor capability with those adapters, and we deliver two main adapters with the CWM. One is the REST API adapter, and the other REST-conf adapter for NSO. On top of that, what we will be talking about later, we have adapter SDK and XDK to develop your own adapter. Now we know what CWM is, how it works. So let's see it in action, and let's create our first workflow. And let's start small with a simple workflow that will use an NSO REST-conf adapter to configure devices with layer 3 VPN service. And this example shows layer 3 VPN in service provider network, and the layer 3 VPN service configures the customer edge and provider edge routers, and the service configuration only references the CE devices for the endpoints in the VPN service configuration. And this example is taken from NSO and examples NCS. I'm pretty sure most of you are familiar with this example. So let's try to configure it with our workflow. So we'll have in our workflow, we'll have two steps. First, we'll configure VPN instance and then configure the VPN endpoints. And this is how this would illustrate into the workflow graph. And we would translate that into JSON or YAML specification, as workflow definitions are based on serverless workflow specification and can be defined either with JSON or YAML. We'll focus here on JSON definitions. So first, we'll define the ID, the name, and the start state for our workflow. And then, as a next action, first action, we'll create VPN, and then we'll configure the endpoints. So let's go now to CWM web interface and let's try to set it up there. So first, what we'll have to do, we have to have the adapters installed. So I have already NSO RESTconf adapter installed, as well as generic REST adapter here. For each of the adapter, we have a worker, and for each each system that will be reaching from our workflow, we'll have created a resource, so NSO resource. Later we'll use NetBox and WebEx. So all the three resources are here. For each of the resources, we have a secret as a way to authenticate toward those endpoints. So now we can start with creating our first workflow, and it will be exactly what we've seen on our first example. So this will be a configure VPN workflow. So let's create a new workflow here. Let's add it a name and version number 1. And once we click on it, we can edit the code of this workflow. So let me just paste here the prepared JSON, the one that we've described before. Again, we use NSO RESTconf post to create layer 3 VPN with VPN name and RD being the parameters here. And then second step, for each of our endpoints, we'll configure VPN endpoint with its name, with CE device, interface, assigned network, bandwidth. And let's save the changes and run this workflow. So when we run the workflow, we should specify the input variables that will be used in this particular run. So for this run, we'll create a VPN instance Volvo with RD999 and 3 endpoints: main office, branch office, and branch office 2. We can see the parameters here like C, interface, IP address, bandwidth. We run the job, and then we can go to job details, see how the run looks like. We can see that it's still being executed. Once I refresh, all green. Let's verify in NSO if this has been configured. We can see there are no VPN service created here. Let me refresh the page, and now I can see Volvo instance with the 3 endpoints configured. All right, so we created the first workflow that uses NSO RESTconf adapter, configures the devices using NSO. What we can add next on top of it, we can create a separate workflow that will be going to reaching NetBox to reserve a prefix that we used before for our VPN configuration. And for that, we'll use the generic REST adapter to post a new prefix towards NetBox API. And we will post the information about subnet IP and mask, and we'll add this description for this subnet that we reserved. All right, let's go back to CWM and create a new workflow for that. And for this one, let's call it allocate prefix. version 1.0, we create a workflow, and again, we go to the code tab to edit the JSON file. I'll just quickly replace it. So what happens here? We have for each action, so for each of the prefixes, and that for each of the endpoints that we actually defined, will be saving the prefix with its IP and description towards NetBox, toward our NetBox instance. And now we can save the changes and run this workflow again with the input variables. In our case here, just IP and description of the subnet. When we run the job, again, we see the details, all green. We go to our NetBox instances and we can see we had no prefixes. After refresh, 3 new prefixes for this VPN that we just configured. We saved it there. So we used here the REST adapter, and as we can see, it can be used for reservation of IP subnet in NetBox. However, that's not the only use case. We have many more use cases that we can use this adapter for. And to give you a few ideas and examples, we could use the same adapter for notification, for messaging like WebEx, for updating data in ticketing system, maybe reaching some database or log system, and many more. Let me show you one last example of this of a workflow with this adapter. In this case, we'll have a very small workflow notifying about completion of the workflow. Let's go back to CWM and let's create one more workflow with let's call it WebEx. And here we'll use the same REST adapter to post message towards WebEx. And the parameter here will be room ID. So when we run, we'll have to pass the parameter as an input. I'm passing the room ID of room where my bot is added and completed in job details. Let me see if it's visible in WebEx. As you can see, I just received this message about workflow completed, and it's completed with success. With that, we have 3 simple workflows that first configures NSO service, second configures posts subnet data to NetBox, and third one notifies about completed workflow. And we can try to put them all together. We can try this reusing of the already created workflows to create one big one that will do all of the above in one single workflow. So in this case, our big parent workflow would you take use of all of them. First, it would reserve subnet in NetBox, then we'll add sync from all the devices, configure VPN, then notify on WebEx about the completion of the workflow. And this is how the WebEx, how the workflow would look like step by step. Let's quickly configure it in CWM. Let's create last one. And let's edit its code. So what happens here is we start with allocating prefixes, and we'll use sub workflow reference towards a previously used workflow to to allocate prefix. Then we'll create another action to sync from. Then we transit to create VPN, and we again will reuse the workflow that we've written before, that we named configure VPN before. And the third one that we again reuse is to report on WebEx to notify us on the completion of the tasks. And then we save it and we can run it again with input containing now we'll try to configure new VPN named Ford with different RD and the endpoints. Let's see what happens when we run it. We see it's still pending. I just got a notification on WebEx. Let me open it for you. That the workflow is completed with success. Now let's check the results in NSO first. We can see we have another instance of layer 3 VPN now, Ford, with these new endpoints and prefixes in NetBox. Now we have 6 of them with new prefixes for Ford VPN here. All right, with that, now we know what workflows are, how do we work with them, and we can start looking into our own infrastructure and see, like a detective, take a close look on what processes we have, which one depends on the other one, and how the results of one can affect another, and what's the order, and what's the trigger, etc., etc. And then try to translate it into the workflows as we have seen before. Now we know what workflows are, how to write them. We can move to part 2 and find out how to create your own adapters. And every adapter is developed for communicating between an intended target and CWM. And the adapters are developed as single Go modules, and they represent the product. And now we will look into how we can create our own adapter. So instead of using generic adapters like we did before, like we did for NSO, we did for NetBox, for WebEx, now we will build an adapter ourselves. And for that, we have SDK and 2 XDKs, one for developing adapters for NSO services and the other one for OpenAPI products. So now let's create an adapter for IP address management data of NetBox. So let me share my Visual Studio Code and we'll go through it together. I'll start with calling CWM SDK and see what I can do there. And shows us many options. What is interesting for us right now is we want to create our adapter. So I issue this comment and see other options that are available that I should provide when I want to create a new adapter. And since I want to generate an adapter for NetBox, I will provide the vendor name as NetBox, product OpenAPI, and the feature I'm interested in IP address management because that's the feature that we've been using for our workflow. And I also choose option ignore template because I do not want SDK to generate the template for that code because I will use XDK to generate the code for the adapter later. So now when I press enter, it creates new project, which I can open here and I can see it generated files that are mostly empty. There's not much happening here. The actual juice of this adapter will be generated with XDK, and here's how we do that. XDK will take an input data, a YAML file that is that we can find for Open API products in their, sorry, not here, in their Swagger specification. So once I open it here I can see an API schema and download the schema YAML file. It's downloading, and I will be using this as a source, as an input for my XDK to generate the actions for my adapter. So what I do now, I will call, first I will go to my new project, and then I will call CWM Open API XDK, and we'll see which options I have here. First, we'll use option to display paths to see the paths that are there inside the YAML file with the API specification for NetBox. So here we can see the description of all the methods, all the URLs, all the methods that we can run towards NetBox API. And the ones of our interest is API IPAM paths. So now we'll generate the codes for these paths. So we again pass our file as a source, use IPAM as a feature, and put the path towards API IPAM. Once generated, we can see that there are plenty more. There's much more data now available in the adapter files for each of the functions, etc. We'll not look into that, but at this point, if you'd like to edit, modify some of these functions, you can go ahead into the code, fix it. If you're satisfied, you can just generate installable, which I'm going to do right now. And once I create installable, it should be available in our out directory. It takes a few seconds. And now I can see my adapter installable that I can now upload into the web interface. And that's what I'm going to do now. So now, once in CWM, I go to adapter and I add this adapter here. I automatically create a worker for that adapter and wait a few seconds for the installation to complete. After it's done, I can update my resource, because before my NetBox resource was using generic REST. Now I want it to use my new adapter as a. So here I fix it, save the changes, and I can update my workflow. The workflow of our interest would be the one to allocate prefixes, and I want to update its code now to use my new adapter. So let me save a new copy of that with version 1.1. And now I can edit my new workflow. First thing that I want to edit is to change my function. Instead of using REST and POST, I want it to be called NetBox POST prefixes, and then I will update the operation. Before it was using generic REST and the request POST method. Now I want to use our adapter with IPAM method and POST prefixes. Once that's updated, all I need to do is update it in our action. Instead of REST POST, I will be using POST prefixes, the one that I named below, and I need to update my data that I provide here. So instead of having this huge input with payload and headers, now I'll provide only I'll provide only my my prefix and the description that I want to have, save changes, and now I can run my workflow. So I'll put input here. Now let's change the IP addresses here because these are the new ones, not the ones that I've been using before. And run the job. Checking job details, looks green, green's good. I go to NetBox, check the results. If they are here, they are here. The subnets with 80. So we can see it worked. So with that, this is how we can create our own adapters. Once we can do that for any Open API standard product, and we have also XDK for NSO services, where we can simplify the uses of the service inside the workflow. And yeah, tomorrow Jay will be conducting the learning lab where he'll be showing more of the XDK towards NSO. And I would like to invite you to participate in that. And also, if you feel like looking into these materials from this session later on, I upload all the codes with the detailed guide of what happened on today's session in my GitHub. Feel free to go there and check and play around with it. And with that, thank you very much. If you have any questions, please ping me, and I will be happy to respond. Thank you very much. Have a nice day. Bye bye.